In OSPF network type, we saw whenever we have NBMA in the middle, non-broadcast multi-access cloud, we can have 5 different approach informing neighbor, 5 different network types. And these are the 5 types. According to RFC 2328, we have 2 types only. So you cannot expect this 3 in a non-Cisco router, but I've seen some vendors do support. These 2 you will definitely see in every vendor. Will see it. It will be there. Non-broadcast is the default type. You may switch to point to multi-point if you don't like non-broadcast. I repeat, you have frame relay as the encapsulation type. Can anyone tell me the default encapsulation type on serial links? What is the default encapsulation type on serial link? Correct. It's HDLC. You may switch to PPP, but PPP cannot support long distance. You need frame relay or MPLS, something like that. MPLS is not our focus. We are focusing on non-broadcast. So frame relay X.25. These are the example for non-broadcast. We switch from HDLC to frame relay. When you do that, this is what OSPF will show you. When you go under IP OSPF interface serial 0, the network type will not be point to point. When it is HDLC, you saw as point to point. Network type as point to point. If you don't remember, I want you to go through the previous class videos. You will find that point to point. That's the default one under the serial link. Whether you run PPP or HDLC, the network type of OSPF is going to be point to point. On the same serial link, when you switch the encapsulation type from the default to frame relay, OSPF will now say, I got a network type called non-broadcast. See, if it is fast Ethernet or Ethernet, it is broadcast. Because Ethernet is a broadcast environment. Frame relay is a non-broadcast environment. I also showed it will be auto-detected. You see, network type will be there somewhere. I think it was auto-detect is the word type. The interface type, the network type is auto-detected depending on what encapsulation and on what link the encapsulation is enabled. Auto-detected. When I configure frame relay, I'm not going and saying OSPF network type non-broadcast. No. That's why we call it as default. Default. When you have frame relay, this is the default. We saw a problem. The problem is the NBMA are always not fully mesh. And there is a DR-BDR elected, which is recommended only when we have full mesh, but we don't have full mesh. DR-BDR is useful only when you have full mesh. The previous class I showed you, if you don't have full mesh, when the hub goes down, you don't have connectivity between the other routers. Then what is the point of DR-BDR? When there is no connectivity. Everything goes through the hub. And when the hub breaks like this, let's say this is DR, and this is BDR, and this is DR other, and this is hub DR other. Now, if hub dies, this will say, I am DR. Who cares? And there won't be any hello coming in between these three routers. After some time, all will say I am DR. Actually, DR-BDR election process itself is a waste here. In hub and spoke topology, it's a waste. But non-broadcast network type will select a DR and BDR. So what do you understand from this? When we don't have full mesh frame relay, we need to switch to the next option, next mode, where there will not be DR-BDR. No other option, you see. You cannot leave this default. This default non-broadcast will have a DR and BDR and DR others, which you may not like because you don't have full mesh. We just saw. Not always full meshed. It's very costly, frankly. For each link, you need to pay money. Let's say for this link, I pay 2 lakh. I need to pay 2 lakh for every link. For full mesh. If it is hub and spoke, I pay only 6 lakhs. 2 lakh, 2 lakh, 2 lakh. I pay 6 lakh. 6 million. But when you want full mesh, you pay 12 million for this 4 sites. Double. Not everyone is ready for that. See, frame relay is that costly. Very costly. So you may not like this default non-broadcast where there is going to be a DR-BDR election. Not only that, in this non-broadcast, neighbors are not automatically discovered. Neighbors are not automatically discovered. Usually when you run routing protocol, PIGRP or OSPF, you saw neighbors are discovered dynamically. We simply say network 10.0.0.0 wildcard mask area ID. Neighbors are discovered automatically. When the hello packets go with proper parameter that matches with the neighbor comes up. So dynamic discovery of neighbor is what you are used to. But this poor non-broadcast will not discover neighbors. The reason is the word itself says non-broadcast. It's a non-broadcast environment, meaning in another word, it's a unicast environment. Opposite of broadcast is unicast. But you know how OSPF hello packets are sent to a multicast. You are dealing with a unicast environment where multicast is not supported. Then how OSPF will form neighbor? Called. That is why here it is said neighbors, OSPF neighbors are not automatically discovered. Not. This is the reason. It's an unicast environment. It's a non-broadcast environment. The multicast can be used. If multicast is not used, then how you will send a hello packet? To whom you will send a hello packet? You do not know the neighbor. When you don't know the neighbor, you use multicast. But when multicast is not supported, then you cannot know the neighbor. See, OSPF uses multicast because it do not know the neighbor. To discover neighbor, it has to use the multicast. After knowing the neighbor, it will start sending unicast. When the neighbor is unknown, multicast support is needed to discover neighbor. We saw that in the previous chapter. Initially, it was sending hello to a multicast address. After one router knowing about the other router, it sent the hello packet using unicast address. We saw that. But to know the neighbor, first I need multicast. If multicast is not supported in that environment, how will you do multicast? How will you discover neighbor? That is why in this default mode, we must configure neighbor manually. If you have this frame relay and the IP address here is 10.0.0.1, 10.0.0.2. Now you have to go to router 1 OSPF and say, I got a neighbor 10.0.0.2. You need to manually specify the neighbor so that router 1 can use this as the source IP and this as the destination IP and send a hello packet. You see the idea? Because multicast is not supported, you need to specify the neighbor's address correctly so that R1 can throw the unicast hellos to discover neighbor. Now, what about this one? This one, dynamic discovery of neighbor. You see, if you don't like this, you can opt for this one. This one, not ready to form neighbor. This one, recommended for full mesh. Because you got DR, BDR election. Full mesh is needed. Neighbors are manually configured. Neighbors are manually configured. Difficult task, if you feel so. You got the next mode to switch. You still have the frame relay. When you make this mode as point to multi-point, then dynamic discovery of neighbor happens, meaning multicast starts working. When it is non-broadcast, as the word says non-broadcast, it's the opposite of unicast, which means it's unicast. Only unicast is supported. Manually, you need to say the neighbor. Whereas when you say point to multi-point, it understands, oh, I need to talk to multiple points. I need to discover neighbor. I need to support multicast. So the dynamic discovery of neighbor happens here. Plus, no DR, BDR. Which means it can be a full mesh, it can be partial mesh, it can be hub and spoke, never mind. This is a very good one to work with any of this topology because there is no DR-BDR. Full mesh is mandate for the first one. For the second one, it is not. For the first one, you need to know the neighbor because you're going to configure the neighbor manually. For the second one, neighbors are dynamically discovered, so no need to know about the neighbor. There is no DR-BDR election. This can be enabled in any topology. Now these two are as per RFC 2328, industry standard modes. You will find in Juniper router, these two. These three which you see down is a Cisco. Additional modes from Cisco. What is the point to multi-point non-broadcast? Cisco has got this one, you see, and this one together. Cisco has got a third mode, which is the combination of first two modes. From that first two, Cisco took the best out of it and came up with a new mode. Best out of the first two. Came up with a new mode called point to multi-point non-broadcast. That's why the name also you see, because it is copied from that first two. Now, according to you, what is the best in the second mode? Second mode. What is the best in the second mode? Try to answer this. What is the best in the second mode? Okay, that is best for you. Okay. What about this one? No DRBDR election. See, when there is no DRBDR election, it is good. It can be used in full mesh or partial mesh or any mesh, any topology. We saw that most of the time NBMA is not always fully meshed. When it is not always fully meshed, this is best according to me. There is no DRBDR election. Which is what I want because I don't have always full mesh. And what is the best on the first one? What is the best on the first one? Manual neighbor configuration is best. Here, neighbors are dynamically discovered. It sounds like a best one, but it is not. It is not best one. Why? Because this is India and this is Australia. And I got a public network here. So forming neighbor dynamically is not safe. Without your knowledge, someone will form neighbor with your router, which is not safe. When you manually configure neighbor, you know with whom your router is handshaking, shaking the hand with. So that is what this is about. No DRBDR. Neighbors are manually configured. Best of that two means this two. In all these three, the hello packets are sent every 30 seconds. And the dead timer is 120 seconds. It is not 10 and 40. In a LAN environment, it is 10 and 40. This is non-broadcast environment, 30 and 120. In all these three, it is 30 and 120. What about this two? As I said earlier in the previous class, you have a broadcast mode and point-to-point mode under NBMA. The reason is, though it is an NBMA, if you wish to have a broadcast experience, or if you want to have a point-to-point experience, if you wish to experience a broadcast feeling in NBMA environment, you can go and switch the mode to broadcast. 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 When you switch the mode to broadcast, you will feel as if you are connected to one LAN switch. When you are connected to LAN switch, what all you experience between the OSPF neighbors, you will see the same experience. What? Neighbors are dynamically discovered. Hello packets are sent every 10 seconds. Dead timer is 40 seconds. There will be DR, BDR. Yeah. You will have all of this. Even though it is an NBMA, you get the advantage of broadcast over the NBMA network. Same way, point to point. If you wish to have a point to point relationship over NBMA, in point to point means how many routers? It should be only between two routers. And the timers are 10 and 40. There is no DR-BDR election. Neighbors are dynamically discovered. Non-broadcast multi-axis இருந்தாலும் எனக்கு சாதாரண ஒரு சீரியல் ஒயரை கனெக்ட் பண்ணி ரெண்டு ரவுட்டருக்கு நடுவில் நெய்பர்ஷிப் ஃபார்ம் பண்ற அந்த எக்ஸ்பீரியன்ஸ் எனக்கு வேணும். நெய்பர் நெய்பர் ஆயிடணும். 10 செகண்டுக்கு ஒரு முறை ஹலோ அனுப்பணும். 40 செகண்டுக்கு அப்புறம் ஒருத்தன் ஹலோவே சொல்லலைன்னா போடா அப்படின்னு துரத்திடணும். டிஆர்பிடிஆரே நடக்கக்கூடாது. இந்த மாதிரி ஒரு எதிர்பார்ப்பு இருந்துச்சுன்னா நீங்க பாயிண்ட் டு பாயிண்ட் மோடை எனேபிள் பண்ணிக்கலாம். அதே மாதிரி தான் ப்ராட்காஸ்ட். என்பிஎம்ஏ மோடா இருந்தாலும் எனக்கு 10 செகண்டுக்கு ஒரு முறை ஹலோ அனுப்பணும். சும்மா கிடையாது. 10 செகண்ட் ஒரு முறை நீங்க ஹலோ அனுப்புனீங்கன்னா பேண்ட்வித் பிடிக்கும். ஃப்ரேம் ரிலே காசு கட்டணும். அதெல்லாம் ஓகேவான்னு யோசிக்கணும். இந்த ப்ராட்காஸ்ட்டும் பாயிண்ட் டு பாயிண்ட் என்ன பண்ணும், ஃப்ரேம் ரிலே டனல் வழியாக 10 செகண்டுக்கு ஒரு முறை ஹலோ அனுப்போம். எங்க இருந்து? இந்தியாவிலேருந்து ஆஸ்திரேலியாவுக்கு. ஹலோ 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 அதுக்கு காசு கட்டணும் நம்ம. இதெல்லாம் ஓகேன்னு சொன்னா நெய்பர் அதுவா டிஸ்கவரி ஆகிடும். 10 செகண்ட் ரொம்ப ஹலோ அனுப்பணும். டிஆர்பிடிஆர் வேணும், நான் ஃபுல் மெசேஜ்னு இருக்கிறேன் அப்படின்னு நீங்க நினைச்சீங்கன்னா, எதிர்பார்த்தீங்கன்னா நீங்க ப்ராட்காஸ்ட் மோட் எனேபிள் பண்ணிக்கலாம். இந்த ஃப்ரேம் ரேல் நடுவில் இருக்குங்கிற ஃபீலிங்கே இல்லாம உங்களை பார்த்துக்கணும். Right. So that last two mode is going to be a LAN environment experience for you. within an enterprise's experience for you, even though you are working on top of NBMA. So if you know that broadcast and point-to-point very well, which we were doing for many OSPF sessions, this is broadcast environment. This is, you see, DRBDR. This is also multi-access, but it is not NBMA. This is within a broadcasting, one switch is there in between to connect this 5 routers. If you have this similar experience over frame relay, you want that similar experience, you can go enable this mode. Same way, if you want to have a point-to-point experience, like this experience, actually you got what? You got a frame relay. Even though you have a frame relay, you don't want to have that limitations caused by frame relay. ஏராளம் தாராளமாய் ஹலோ பாக்கெட்டை தள்ளி அனுப்பு 10 செகண்டுக்கு வரும்போது இந்த ஹலோ பாக்கெட் வேணுமே வேணும். If you feel like that, then you can go with this 5th mode. But you need to know one thing again, I'm reminding you need to pay for the frame relay hellos. OSPF hello which consumes frame relay provided bandwidth, which is very costly. All right, now let's see again one more round. This 5 mode, then we will get into lab. In this first 3, no. In this first 4, all the neighbor participating router, the routers that participate in neighborship, they will all be in same subnet. But in point-to-point, each point-to-point will be in different subnet. Let me explain you. In that first 4, router 1, router 2, router 3, router 4 will be in same subnet. Will be in same subnet, meaning what? 10.0.0.1, 10.0.0.2, 10.0.0.3, 10.0.0. You got frame relay here. But you cannot make point to point because it is in same subnet. If it is point to point, how it should be? When you say point to point, how it should be, let's say this is the head office. You will have one physical interface, but you will create sub interfaces. How many? 3, because I have 3 sites. R1 10.0.0.1, here 10.0.0.2. This is one point to point. R1 20.0.0.1, 20.0.0.2, another point to point. R1 30.0.0.1, 30.0.0.2, another point to point session. So there is no DR-BDR between these two. This is one physical wire. These 3 are sub-interface. But here is physical wire, physical port, physical port, physical port. Different subnet with each neighbor. Different subnet with each neighbor. Whereas in the first 4, all neighbors are in same subnet. I hope you understood the word same subnet between neighbor, different subnet between neighbor. Any question? See, the reason why we create subinterface here is we need to form neighbor with three routers, and all those three router 2, router 3, and router 4, they are not in same subnet. They are not in same subnet. So what I do is, if I want to form neighbor with those three which are not in same subnet, I need to have three different connections, but I cannot afford three different connections. So what I do is I create sub-interface. One interface I give the subnet of router 2, another sub-interface I give the subnet of router 3, another sub-interface I give the subnet of router 4. Yeah. Question, please. Now, சொல்றது புரிஞ்சுதா? You cannot use different subnets in point to multipoint. Then it cannot be considered as point to multipoint. If you have routers 10.0.0.2, 10.0.0.3, 10.0.0.4, 10.0.0.1, there is no need for you to create point to point. There is no need because these four are of same subnet, same group. It's first of all, it is not possible if you try, you know, if you do point to point in this scenario, not good because there will not be a DRBDR. Here, DRBDR is mandated to prevent duplicate updates and loop. So you cannot first of all configure point to point when you got multiple routers with same subnet. The point to pointங்கிறதுக்கு மரியாதை இல்லாம போய் பாயிண்ட் டு பாயிண்ட்னா ரெண்டு பேர் தான் அதுல இருக்கணும். ரெண்டு பேருக்கு மேல இருந்தா அது பேரு பாயிண்ட் டு பாயிண்ட் இல்லை. So you cannot have point to point mode here. Likewise, you cannot have point to multi-point mode here because you don't have multiple points in same subnet. This is in different subnet, then this and this. They're all in different subnet. You cannot call them நாங்க எல்லாம் ஒருத்தர் தான், ஒரே கும்பல் தான். No, you cannot say that. I am 10, he is 20, she is 30. Yeah. So this need to be point to point only. So there is a relation here, point to point. There is another relation here, another point to point. There is another point to point relation. Whereas here, we are all one group. Yep. Question, please. No questions? Okay. So same thing what we saw, we are going to repeat one more time. Here I have three different subtypes. I have not included broadcast and point to point here because it is same like within an enterprise. So the default mode is non-broadcast. Neighbors need to be manually configured. So we are just doing a revision now. There will be a DRBDR. No multicast is used. So this is recommended in full mesh. Because you are configuring neighbor manually, the hello packets are sent using unicast to the address that you manually defined. More complex to configure because each neighbor must be manually specified. If you have 10 neighbor, you have to know the address of 10 neighbor, and you need to go to each router and configure nine neighbors. And there will be a DR BDR election to avoid loops and duplicate updates. Second point, point to multi-point. As I said, though it is multiple point, it will treat like a point-to-point. In point-to-point, there is no DR-BDR election. In that way, it treats like a point-to-point. Multicast is used so that neighbors are dynamically discovered. Again, the media should support, frame relay should support multicasting. It is supported by ISPs. Okay, so this can be used in any topology, even if it is partial mesh, it is okay. Simplified, simpler configuration than the first one. Neighbors can be dynamically discovered because multicast is supported. Each neighbor is treated as a separate point-to-point connection, though they're all in same subnet. They are considered as separate according to OSPF, not routing logic. What our Sangeeta ma'am was asking is routing logic. In routing logic, no, they cannot be. But this is a privilege of mode provided by OSPF. Even though they're all in same subnet, each neighbor is considered as separate point-to-point according to OSPF formally. And the third one is combination of both. Like point to multi-point, what do you mean? See, in point to multi-point, the best thing is there is no DR-BDR election. And then, like non-broadcast, like non-broadcast. Like non-broadcast, no multicast support. So neighbors need to be manually configured. Neighbors need to be manually configured. And again, there is no DR-BDR, so it can be used in hub and spoke or partial mesh. Manual neighbor configuration is like here. All right, same thing. DR-BDR election in a non-broadcast. Yes. Neighbor discovery, no. Manual. Multicast support, no. Best for full mesh. Hollow packets are sent using unicast. The second one, point to multi-point. Neighbors are dynamically discovered. Dynamically discovered. No DR-BDR election. And multicast is supported. Dynamically discovered neighbor. That's how it happens. Partial mesh. Multicast. Hollow packets are sent using multicast. In point to multipoint on broadcast, this is the difference. Hollow packets are sent using unicast because you are going to send the neighbor address. You're going to say the neighbor address. Why? Because there is no multicast support. All right. The neighbors are manually configured. There is no DR-BDR election. Right. In the next class, we are going to do this lab with frame relay, and we are going to test. So what we will do now is